Hi everyone, welcome to my channel, Tortellini Test Prep. Today I will be providing a full walkthrough of the digital PSAT NMSQT Math Practice Test Number 2. The digital PSAT NMSQT is a preliminary SAT exam often taken by American students in the 10th or 11th grade. The exam is incredibly similar to the SAT, so you should watch this video even if you are only taking the SAT. I highly recommend you complete the exam yourself before watching this video. You can use the chapters in the description to quickly jump between the three modules. Let's get started with Module 1. This is the beginning of Module 1. Question 1. Alright, so for this one, it says that I have vitamin D and calcium has a total mass of 150, so that probably means we're going to add. So I'm going to do D plus C equals 150. They tell us that the vitamin D in the mixture is 50 grams. So D is 50. So I'm going to make 50 plus C equals 150. I'm going to subtract 50 from both sides, and I will get C equals 100, which gives us answer choice C. Okay, question 2. So first I am going to solve this equation. So 2x plus 3 equals 9. I'm going to subtract 3 from both sides. I get 2x equals 6. And then I'm going to divide both sides by 2, and I get x equals 3. But there's a follow-up question, so make sure you answer that. It says, what is the value of 6x minus 1? So I'm going to do 6x minus 1. X is 3. We get 18 minus 1, which is 17. And that is the answer. Let's do it on Desmos as well. All right, so I'm first going to just type that equation in verbatim. 2x plus 3 equals 9. I go to the graph, just look where it intersects the x-axis, double click, and I see the solution is 3. If you want to make the substitution easier, you can replace x with a constant. How about lowercase a? So a equals 3. And then instead of typing 6x minus 1, I'm going to type in 6a minus 1, which is 17. Great. Okay, question 3. So first thing I'm going to do is add all these up to get the total. So if you do all that on your calculator, 119 plus 3 plus 35, you should get 157. And probability is the desired outcomes over the total outcomes. And the question says if one of the gemstones, so they're all gemstones, so that means out of everything. So our total is going to be 157. Selecting a gemstone with color Y. So we're going to do 3 desired over the total of 157. And that gives us answer choice A. Okay, question 4. So this question wants us to find the y-intercept. And you should know that when the equation of a line is written in the form y equals mx plus b, m is the slope, and b is the y-intercept. So I can quite literally just look at this and see that the y-intercept is 81, which gives me answer choice A. You should also know that to find an intercept, you make the other letter equal to 0. So for a y-intercept, if I plug in x equals 0, I get y equals 34 times 0 plus 81, and I get y equals 81. And since x was 0, that means it's 0, 81. So to find a y-intercept, plug in x equals 0. To find an x-intercept, plug in y equals 0. We can also do it on Desmos. Let's go do that now. Okay, all I did was type this equation in. If I click here, it tells me the y-intercept, and if I click here, it tells me the x-intercept. There might be a trap answer that's the intercept you don't care about, so just be really careful you don't mix them up. The y-intercept crosses the y-axis, and the x-intercept crosses the x-axis. Great. Okay, question 5. So this is kind of hard to do on a digital exam, but you guys see if I draw the approximate line of best fit, just try to go through the middle of the data. As I go left to right, the line is going up. The y values are getting bigger. So that means the slope is positive. So the slope, or m, should be positive. If it were going down as you go left to right, that means the slope would be negative. So you see here, A, B, and C all have negative slopes. Looking at y equals mx plus b. M is the number in front of the x. But we have a positive slope, positive 0.9 for answer choice D. So I don't even need to do any more work. That must be our answer. Okay, question 6. So if you haven't watched it already, guys, definitely go check out my Ottocento number 2 on unit conversions. You can get a lot of practice on that. I'm just going to assume you've already seen that. So first I'm going to write down what they told me, 77 rods. Then I'm going to set up a parenthesis. And I'm going to put the unit that I want to get rid of on the opposite side of the division sign. So this rods, I'm going to put 1 rod on the bottom and 5.5 yards on the top. And you see those are on kind of like, see how they're kind of like on opposite sides of this little fence here? That means you can cross out the unit. And if you type this in a calculator, you should get the converted length in yards. Now, this question isn't super convoluted, but I'm going to encourage you to type it in exactly as written, because as these get more complicated, you'd hate to get it wrong just because you typed it in the calculator wrong, right? And that can happen as these problems get harder. So the answer is 423.5 yards. If you input the fraction 847 over 2, that would also be acceptable. Great. Okay, question 7. So you can use rise over run to find the slope of this line. However, that can be kind of hard to do on a digital exam. If you hold your finger up to the screen, maybe you can do it. But I'm just going to go over slope formula. Why not? So this first point here, that's 0, 5, and this other one is 1, 9. Slope is y2 minus y1 over x2 minus x1. I have a short on this. You can check it out if you want. So I'm going to call this one x1, y1, and this one x2, y2. So 9 minus 5 over 1 minus 0. That should give us 4 as the rise. The run is 1, and we get 4. Now, that's not necessarily the final answer, because it says here we want to find the slope of the parallel line, which is not shown, line K. Well, parallel lines have the same slopes. So the parallel slope is also 4, and that is the answer. Great. Okay, question 8. So you'll notice for all these answer choices, they all have the same inequality symbol. So you don't really need to worry about the boundary line or the shading. So what we're going to do is I'm just going to look at kind of maybe the slopes, and the slopes are all the same too. They're all 2/3. So let's look at the y-intercept. Well, the y-intercept here is minus 6. So in y equals mx plus b, b should be -6 because that's the y-coordinate of the y-intercept. And you see the only one with that as an option is answer choice A. You can also guess and check by simply typing in the answer choices. And just when you'll notice, oh, it looks pretty much exactly the same. I would just encourage you to pay close attention to the intercepts. So you can see the intercepts are -6 and 9, and that's what the picture shows us as well. So looks good. Okay, question 9. So from the reference sheet, the area of a circle is pi r squared. And they tell us that the radius is 43. So that tells me r is 43. And you can either use a scientific calculator, which can simplify with pi, or you can just kind of type in just 43 squared on your calculator and then just remember to slap a pi at the end. Either way, 43 squared is 1849. So you get 1849 pi. And that is the answer. Definitely get in the habit of finding area and stuff like that exactly in terms of pi, because the SAT has you do that a lot. Great. Okay, question 10. They tell us in this equation that x is equal to 300. So I'm just going to replace x with 300. That's it. And let's see, 300 divided by 30 is 10. And 16 minus 10 is 6. So we get the amount of gallons is 6 gallons. Great. Okay, question 11. So we have a triangle ABC. And it says that AB, so that's this one, is 4680, and BC, that's this one, is 4680. And it wants to know what must be true for the triangle ABC to be equilateral. So the two things you need to know about equilateral triangles: all the sides are the same, and each of the three angles are 60 degrees. So I don't see anything about angle measurements in the question. So they must want us to know that this side, AC, must also be the same length. And that is answer choice A. Okay, question 12. So first thing I'm going to do is just write down this stuff that they kind of told us at the end of the question. So P of 8 is approximately equal to 32.91. And this is really important, guys. The thing inside your parentheses is the independent variable, or your x. In this case, the independent variable is t. So I'm going to label this guy with a t. And then the number over here is your dependent variable, which is in this case the y, or the name of the function, in this case capital P. See how I'm kind of pulling that from over here? So I'm going to call this guy capital P. Now I'm just going to pick out what T and P mean directly from the paragraph and write it down without looking at the answer choices at all, so that they don't trick me. So I'm going to look at here, it says T is the number of years after 1984. Okay, so when T equals 8 years after 1984, and if you do some quick arithmetic, 1984 plus 8 is 1992. And then let's look where it talks about the function P. It says the function P gives the predicted population in millions of a certain country. So the population is roughly equal to 32.91 million people. So now that I've come up with the interpretation myself, now I'll start looking at the answer choices. And you can see, if you look at answer choice C, there's a lot of good stuff going on there. It says 8 years after 1984, the population was approximately 32.91 million. And that's exactly what we came up with. If you look at all these other answer choices, this one says in 1984. I don't even need to read the rest. There's no way that's right. We just established it's in 1992. This one also says in 1984, wrong for the same reason. And then this one says 32.91 years after 1984. I don't even need to read the rest. We established that it is 8 years after 1984. So make sure you pay very close attention. The letter inside, the number inside the parentheses is the letter inside the parentheses, and then the number on the other side is the name of the function, the letter outside the parentheses, or your dependent variable. Great, let's keep going. Okay, question 13. If you haven't already, please watch my Ottocento number 11, which is on SOHCAHTOA. Just going to assume you've watched that. All right, so we want to find cosine of A. So I'm going to circle the angle of interest, and then I'm going to do HOA, hypotenuse, opposite, adjacent. So the hypotenuse is across from the right angle. The opposite is across from the angle of interest, and the adjacent is your third side. So now SOHCAHTOA, C-A-H, so cosine is going to be equal to adjacent over hypotenuse. So I can see that the adjacent is 41 and the hypotenuse is 42. And that gives me answer choice B. Great, let's keep going. Okay, question 14. So it says we got a line segment and it's cut into 3 parts. So I'll just draw a line segment and I will cut it into 3 parts. One of the parts is 47 and the other 2 parts are equal. So how about these 2 parts are equal, and I'll call each of them X. And it says the total length of the segment is 115. So this is called segment addition. So all those tiny segments must add up to the big overall one. So 47 plus X equals 115. That gives me 2X plus 47 equals 115. I'm going to subtract 47 from both sides. And I get 2X equals 68. And then I'm going to divide both sides by 2. And I get X equals 34. And that is what the question wanted, just one of the equal parts. So that is our answer. Okay, question 15. So mean is equal to sum over n. And if you add up all those numbers, you should get 18,150. And n is the number of data points. They tell you that, but you could also just count them 1, 2, 3, 4, 5. So there, we're going to make n 5, so we'll put 5 on the bottom. 18,150 divided by 5 should give you 3630. We could also compute the mean of a list on Desmos. Let's go do that now. Okay, first things first, guys. I have a really vertical application window, but I would encourage you to just drag this right, because we're not going to plot anything. So if you drag it further to the right, you'll be able to see the numbers you're typing in better. Like I said, it's just the way I have the recording set up that I can't really do that much. So I'm going to make a list, 4010, using a square bracket, 4010, 3030, 4050, 3050. And I can very quickly just learn whatever I want to know about this list. So mean of A is 3630, median of A is 4010. And if you wanted to say, like, figure out the range, you could very quickly see the max and the min and do max minus min. So yeah, we get 3630. Looks good. Okay, question 16. So I'm going to highly encourage you guys, I'm just going to assume you've watched this already. I have a short on discriminant. I think it's my most viewed one. So if you go to my shorts tab and sort by popular, it's like the very first result. So to figure out how many solutions a quadratic in standard form has, we're going to use the discriminant b squared minus 4ac. So you see we have an a of 1, a b of negative 12, and a c of 27. So I'm going to do negative 12 squared minus 4 times 1 times 27. If I type that in a calculator, I get 36. And that means the discriminant is positive. So it has 2 real solutions. You can learn more about the discriminant by going to watch that short. And the answer is A. We can also do this entirely on Desmos. Let's go check it out. Okay, guys, I would encourage you not to just type the equation in. Whenever you're curious about the number of solutions, you don't care what they are, you just want to know the number of solutions, you should break it up into a system. So note that I typed in y equals the left-hand side of the equation, which was x squared minus 12x plus 27, and then y equals 0, which is the right-hand side of the equation. And the solutions are the point of intersection. You see there is 2 of them. Okay, question 17. So the first thing we're going to do when we're trying to find the equation of a line is we're going to write the partial equation. So put the slope in, so y equals 2x plus b. Next, we'll plug in a point to solve for b. So the point they gave us was 1, 14, so we'll do 14 equals 2 times 1 plus b. So 14 equals 2 plus b. Subtract 2 from both sides, and I get 12 equals b. So now I'm going to go back to my partial equation and put that in here. And we get y equals 2x plus 12. And that is answer choice C. We can also do this one entirely on Desmos. Let's check it out. Okay, first thing I'm going to do is type in the slope, m equals 2. Next, I'm going to make a table to put the point in, which is 114. And finally, I'll use, I'll regress slope-intercept form. So y1 tilde mx1 plus b. And you see in the parameters, it tells me b equals 12. So that means y must equal 2x plus 12. Let me just check to make sure I got that right before I lock in my answer. It does look good, and it goes through the point. We got the same thing. Looks good. Okay, question 18. So density is equal to mass over volume. So we got a mass of 168 over a volume of 24, which gives us a density of 7. That is answer choice A. They don't expect you to memorize the density formula, though you might just want to know it. You could figure it out by kind of saying like, oh, density, and then the units kind of tell you, okay, you see how it's like a unit of mass, and then this word per, which means division, by a unit of volume. So you could figure it out by doing some like unit analysis, but you probably just want to know D equals M over V. Okay, question 19. So definitely check out my Ottocento on percents. I'm just going to assume you've already watched that. And definitely check out my shorts on exponentials plus time. There's 3 of them in my shorts tab. It's a 3-part kind of series of videos. All right, so really all I'm seeing here is that it says each month we have a 7% greater. That's a 7% increase of the previous month. So we're essentially doing the percent multiplier for a 7% increase. If you watch my percent multiplier video, I talk about how to find an increase multiplier. It's 1 plus percent over 100. So we're going to do 1 plus 7 over 100. So the multiplier is 1.07. And in a times b to the x, b is the multiplier. So you see the only one with a multiplier of 1.07 is answer choice B. One last thing, I want to point out that you should always be doing percent arithmetic on Desmos. I don't care how simple it seems, you should be doing it on the calculator on autopilot, because they will give you percents that seem easy to work with, but they really aren't. And then there'll be convincing trap answers on future questions. So please do these on the calculator. You will regret it if you don't. Okay, question 20. So first thing I'm going to do is isolate the p of x. So I'm going to subtract 57 from both sides, and I get p of x equals x squared minus 57. Now I'm going to do h equals minus b over 2a to find the x coordinate of the vertex. So the vertex b, you'll notice there's no x term, right? So you'll notice that b is just 0, and 0 divided by anything is 0. So h is just 0. And if you plug in 0, I suppose I should say p of h, but I'll write f of h. If you plug in 0, you get negative 57. So the vertex is 0, negative 57. And the minimum value, they want a y value. So it wants the y value of the vertex, which is negative 57. And we can, all these formulas and everything, I go over in Ottocento number 13, basic quadratics. Definitely make sure you watch that. All right, we can also do this one entirely on Desmos, so let's go do that. Okay, so you could type in what we came up with for p of x. You could also just mentally replace the p of x with a y. It doesn't matter, do whatever you want. And I'm gonna find the vertex. Okay, the vertex is down here. And it's 0, negative 57. So if they ask me, what's the x value where the minimum takes place? I would say 0. But if they ask me, what's the minimum value of the function? Then I would say negative 57, the y value. Great, let's keep going. Okay, question 21. So once again, guys, in my Ottocento number 1 on percents, I go over this exact question a bunch of times. Also in my shorts on percents. So if you go to my shorts, there's like 5 shorts on percents, I think. You'll see me go over this. So that 0.35 is a percent multiplier that we are applying to the x. So to find the percent change from a percent multiplier, we use the equation 100 times the percent multiplier minus 1. So I'm going to do 100 times 0.35 minus 1. That should give you negative 65%. And the negative we verbalize as a decrease. So it's a 65% decrease. And that is answer choice D. See how it says result of decreasing? That's a good sign that we expected to get a decrease, and the formula told us we got a decrease. That means we probably did it right. It's a good sign. And remember, guys, always do percent calculations on Desmos. You'd hate to make a careless mistake with the arithmetic. Okay, question 22. This is an old SAT favorite called a mixing problem. So when I do these, I like to use kind of like a weighted average formula. P1 capital X1 plus P2 capital X2 equals P total capital X total. And you can replace the X's with like M's if you want for mass, or a lot of times they do this with like cups of liquid. So you could call it like V for volume, P1 V1 plus P2 V2. Again, that's just how I like to think about it. All right. So the total mixture is going to be 50 grams, 50% silicon. So we're going to do 50%, so that's 0.5, and a total mass of 50. And then it says down here we've got 30% silicon pi mass for the first part. So how about I call him 0.3, and then I call this guy, we don't know, they didn't tell us, so why don't I call him little x? And then the second piece was 80% silicon by mass. So we'll call P2 0.8, because 80 divided by 100 is 0.8. And how about I call this the missing mass y? And then there's another equation. If we combine both those masses, we should get the total mass. Think back to like my cup liquid stuff I was talking about before. If you mix 2 cups of water, if you have like 2 cups and 3 cups, you get 5 cups if you put them together, right? So it's kind of the same idea here. So I'm also going to write x plus y equals 50. This one has to add up to this one. Hopefully that kind of makes sense. And you could go and solve that by hand using substitution or elimination. It would kind of be silly to do though, because we should really just use Desmos. So let's go do that. Okay guys, this is the beauty of naming your variables x and y, is you can just type in the equations. So we get x equals 30 and y equals 20. Let me write that down. Now we have to read the question very carefully. So the question says, we want to know the mass of the silicon. Not the total mass, the mass of the silicon in the second piece. So that's this part, the 80% silicon by mass. So I'm going to do 80% of the total mass of that second piece, which is 20. And let's just come over here and see what that is. 16. So there is 16 grams of silicon in that second piece, which gives us answer choice B. Okay, this is the beginning of module 2A. Let's get started with question 1. So it wants us to find the how many containers have 78 walnuts. So I'm going to look at this bar chart and I'm going to look at the 78 walnuts bar. And it looks like that is 7 containers, which is answer choice B. Okay, question 2. So this is essentially just asking us, see how it says 10% are red, 10% of these marbles are red, and there's 320 marbles. So this is essentially just asking us 10% of 320. You can do that on Desmos very easily. However, you need to know how to do it by hand as well for later questions. So I'm going to do it by hand. So 10 over 100. Change the of to multiplication. I go over this in my percents video, my Ottocento percents video. 10 divided by 100 is 0.1. And 0.1 times 320 is 32, which is answer choice A. So divide the percent by 100 and change the of to multiplication. Okay, question 3. We're going to do rate times time. So 60 items per hour times 3 hours. You'll notice the units cancel and we're left with items. So we get 60 times 3 is 180 items. And that is our answer. Okay, question 4. So we want to find the y-intercept. So we look where the line crosses the y-axis, which is right here. The x-coordinate is 0. And the y-coordinate is 2. So the y-intercept is 0, 2, which is answer choice C. Okay, question 5. I don't think I have a designated video on absolute value equations, so let me briefly pull up a set of notes that you can copy down if you want. Okay, so we always first isolate the absolute value. We don't do distribution or anything on absolute values. We get it by itself. If the absolute value is equal to a negative number, it has no solution. If the absolute value is equal to 0, it has 1 solution. And if the absolute value is equal to a positive number, it has 2 solutions. For 1 solution, all you do is drop the bars. That's fine. But for 2 solutions, this is what messes everybody up. So you have to drop the bars. That's one of the equations. And then the second equation is if you drop the bars and multiply the right side by a negative. So see how I have x minus 4 equals 2 and x minus 4 equals negative 2. Great, let's go back to the question. Okay, so for this one, the absolute value is already isolated, and we have a positive number on the other side. So that means it has two solutions. So let's write that down. Two solutions. So we're going to write two equations. So x plus 5 equals 48. And then x plus 5 equals negative 48. I solve both of those the exact same way by just subtracting 5 on both sides. On the right one, I get x equals 43. Sorry, 45. I messed up. Here, let me look. 45. Subtract 45 on both sides, I get x equals 3. And then for the left one, I subtract 45 on both sides, and I get x equals negative 93. And they want the positive solution, so we're going to go with this one, which is answer choice A. We can also do this one entirely on Desmos, so let's go do that. All right, so we could just type in the equation verbatim, but for whatever reason, Desmos does not like it when it won't let you click on the solutions when you have an absolute value for some reason. So let's break it up into a system. Y equals absolute value x plus 45, and then y equals 48. And I'm going to zoom out. Okay, so we got a solution right there and right there. So you see the solutions are negative 93 and 3. And very common question is to ask you the sum of the two solutions. So that would be negative 90. Again, the answer to this question is 3. Just trying to help you guys prepare for future questions. Okay, question 6. So for this one, they want us to find a probability of snow of 30%. So I'm going to look there on the graph, and I see that that happens on Thursday, which is answer choice C. Okay, question 7. So the concept here is that the solution to a system is the point of intersection. So where the two graphs meet. And you can see they actually put this nice dot here so that we don't miss it. Maybe because they think it might be hard to see on a computer screen. I don't know. But the x-coordinate is negative 2. The y-coordinate is 6. So the solution is negative 2, 6. And that is answer choice B. Okay, question 8. So they actually gave us one of the variables solved, so that's great. So let's kind of put that in. Let's substitute that into the equation. We get y equals 5 minus 4, and 5 minus 4 is 1. We can also do this one entirely on Desmos, so let's go do that. Okay, I just typed this in. I click on the point of intersection, and it tells me it's 4, 1. So the x value is 4, and the y value of the solution, which is what the question wants, is 1. Okay, question 9. So question says at least 67. So at the end, I'm going to put at least tells us to put a greater than or equal to sign. And I'm going to put 67. And here it says we already have 63, and we want to know how many additional we need. So I'm going to do 63 plus, we don't know how many additional, so I'm going to say x. All right, to solve this inequality, I'm just going to subtract 63 from both sides. We get x is greater than or equal to 4. Kind of seems like it's supposed to be an integer, but again, it doesn't really matter because x is greater than or equal to 4, so 4 is included in that solution set, so we can just put 4. Okay, question 10. Once again, we want to find the y-intercept, so we're looking where the graph crosses the y-axis, which is right there. The coordinates of that point, if I read the graph, are 0, 40. And they want to know the y value, which is 40. Okay, question 11. So first thing I'm going to do is always, before you move stuff, is combine any like terms on either side. We have this 8x and this 7x on the left side. So 8x minus 7x is 1x, or just x. Everything else stays the same. Now I'm going to subtract 130 from both sides. And I get x equals 130. We can also do this one entirely on Desmos, so let's go do that. Okay, I'm just going to type the equation in verbatim. You guys can see I did that. There's nothing weird going on. No fractions, no square roots, no absolute value, nothing that's going to prevent me from clicking on the solution. I'm zoom out, and I see that the solution to the equation is 130. Okay, question 12. Question wants us to find the x-intercept. That's where the graph crosses the x-axis, which is right here. I read the graph, and that is at 6, 0. And the question wants the x-coordinate, and the x-coordinate is 6. Okay, question 13. So this one-time activation cost of $35, that's what we call in America a flat fee. Flat fees are usually your y-intercept. So in mx plus b equals 35. And then this keyword, monthly, daily, yearly, anything like that, probably a slope. So the slope is 23. So y equals mx plus b. So y equals 23x plus 35. If you use the letters in the question, that gives you c equals 23t plus 35, which is answer choice C. Okay, question 14. So to find f of 7, what we're going to do is we're going to replace all the x's, what's inside the parentheses, with a 7. So f of 7 equals 3 times 7 minus 8. That's 21 minus 8, which should give you 13. So f of 7 is equal to 13. That is answer choice B. We can also do this one entirely on Desmos. Let's go do that. Okay, so I just type in this equation verbatim, and then to evaluate the function, you just type in the function notation. So f of 7, and I get 13. Okay, question 15. So this concept is called vertical angles. So for vertical angles, when you have this kind of X shape, the angles across from each other in the X are congruent. So if W is 136 degrees, as this question says, then Z must also be 136 degrees. And that is the answer choice D. It's worth pointing out that you can quickly find those two blue angles as well. You might have to do that on a future question. So these guys are supplementary. They add up to 180. So I'm going to do 180 minus 136. And I get 44 degrees. So both of these guys are 44 degrees. Make sure you can quickly find all 4 of those angles given just one of them. Okay, question 16. So the area of a rectangle given on the reference sheet is area equals length times width. It says here that the area is 57, so I'm going to make A 57. And the longer side, the length, is 19. So I'm going to replace the L with a 19. So I get 57 equals 19W. If I divide both sides by 19, 57 divided by 19 is 3. So I get a width of 3. And that is the answer. Okay, question 17. So all we're going to do, just kind of by taking a little peek at the answer choices, all we're going to do is we're going to distribute. So 19 times x squared, that's just 19x squared. And 19 times negative 7, that's negative 133, which gives us answer choice A. We could also do this one entirely on Desmos. Let's go do that. Okay, so all you got to do is type in the expression from the question when there's just a single variable like x here, and then type in the answer choices and see which one has infinitely many solutions. That's what equivalent means. So if I type in answer choice A, you see it perfectly replaces the expression in the question. So that means A is the answer. If you go on your own and type in B, C, and D, you will see that they do not perfectly overlap. So that means they're wrong. Okay, question 18. So just like the one we did a question or two ago, we're going to replace all the x's with what's inside that parenthesis, in this case 0. So 10, 0 squared minus 32 times 0 minus 152. And 0 times anything is just 0, so these guys both kind of go away. And we're just left with f of 0 equals negative 152, which is answer choice A. We can also do this one entirely on Desmos, so let's go do that. Okay, so I just typed in the equation verbatim, and now I'm going to type in f of 0. It tells me negative 152. You'll notice that if you look at the graph, that the y-intercept is negative 152. So negative 152 is the y-intercept, which when we do quadratics, ax squared plus bx plus c, we call that c. So if you knew that c and f of 0 both meant the y-intercept, you could have just looked at this part of the equation and figured out that f of 0 was negative 152 super quick. Okay, question 19. So we are going to, they give us one of the variables again as just a number, so that's great. So we're just going to plug that into the other equation. So we get y is equal to 15 minus 3 squared. 15 minus 3 is 12. 12 squared is 144. That's important. Going to put a box around that. But that's not the answer. The question wants the value of x, y. So x they said was 3. Y we just figured out was 144. And 3 times 144 is 432. And that is answer choice A. We can also do this one entirely on Desmos, so let's go do that. Okay, so x equals 3, y equals 15 minus x quantity squared. We're going to see where they meet. 3 comma 144, so they want xy, so 3, 144, which is 432 as well. Okay, question 20. So the product of two positive integers is 462. Product means the result of a multiplication. So x times y equals 462. Now it says the first integer, which you'll notice I called x, is 5 greater than twice the second integer. So x is means equals, and then twice the second integer is 2y, and 5 greater is plus 5. So we've got this nice system of equations. X is by itself, so we could substitute it in here. And if you do that, you would get 2y plus 5 times y equals 462. 2y squared plus 5y. And then if you subtract the 462 over, it would look like this, 462 equals 0. You would then go and use quadratic formula or the AC method, but doing AC method on numbers this big, like 2 times 462, is going to be like pretty much impossible. So please just don't bother doing that. Let's just go switch to Desmos and we'll type this in. So again, beauty of using x and y is you can literally just type them in. All right, so there's two options, negative 28, negative 16.5, but those are negative, and one of them's not even an integer, so it's not that one, it's this one. X is 33, and y is 14. So it says, what is the smaller of the two integers? So we are going to go with 14. Okay, question 21. So for this one, I definitely recommend you check out my Ottocento number 4 on factoring. We're going to be using what's called, I'm just going to assume you've watched that. We're going to be using what's called difference of two squares factoring. Difference of two squares. So the 17, can't really factor that. So I'm going to factor the x squared minus 100y squared. The square root of x squared is x, and the square root of 100y squared is 10y. So we're going to do a plus b, a minus b. So x plus 10y, and then x minus 10y. And that gives us answer choice D. Okay, question 22. I definitely think you need to watch my Ottocento number 6 on linear systems. I go over exactly how to do this in tremendous detail, and there's a free worksheet you can do to practice. So I'm just going to assume you've watched that. So just like in the video, I'm going to set up a proportion. One second, let me just highlight these constants to make it easier for you guys what we're kind of doing. All right, so ax plus by equals c, dx plus ey equals f. So negative 12 over negative 6, 14 over 7, and then 36 over negative 18. So now I'm going to simplify all of them. So this first one is 2, 14 divided by 7 is 2, and then 36 divided by 18 is negative 2. So the first ones, I put an equal sign. That tells me it has the same slope. And then the second ones, I put a not equal to sign. That tells me it has different y-intercepts. So same slope and different y-intercept means the system has no solution, or in other words, zero solutions. And that is answer choice D. We can also do this one entirely on Desmos, so let's go do that. Okay guys, so all I did was just type the equations in verbatim. You can see that the lines are parallel. Parallel lines have no solution. This is the beginning of Module 2B. Let's get started with question 1. So it says intersects the y-axis at this point. Essentially just wants us to find the y-intercept. So we look at where the graph touches the y-axis, which is right here. I read the graph that is at 0, 7. It wants to know the y value, which is 7. Okay, question 2. So question wants us to find g of negative 7. So we're going to replace all the x's. Whatever's in parentheses, we're going to replace all the x's with a negative 7. So 4 parentheses negative 7 minus 6. We get negative 28 minus 6. And that means g of negative 7 is equal to negative 34. And that is answer choice A. We can also do this one entirely on Desmos, so let's go try that. All right, so we just type in the function verbatim, and then I'm going to type in g of negative 7, and we also get negative 34. Okay, question 3. So the question says we have at least 67 samples. So at least means to use a greater than or equal to sign. So I'm going to write greater than or equal to 67. Now the rest of the question says he already has 63 samples, and we want to know what is the minimum number of additional samples. So I think I'm going to do 63 plus some variable. So how about I write 63 plus x. To solve for x, this inequality for x, we're going to subtract 63 from both sides. We get x is greater than or equal to 4. So the minimum number of additional samples that the geologist needs is 4. Okay, question 4. So perimeter is the sum of the external edges. You can make a picture if you want, but essentially they gave us 2 of the sides, and we want to find the third side. So the sum of the edges is 4 plus 7, and then you could either call it BC, or how about I just call it X? And that has to add up to the perimeter, which is 17. So we combine the like terms, we get 11 plus X equals 17. And then we subtract 11 from both sides, and we get X equals 6. So the third side, side BC, is 6, which is answer choice B. Okay, question 5. So right away, I noticed that B, the y-intercept, is 4. That means that 0, 4 must be on the graph because y-intercepts always have an x of 0. And I notice immediately that the only table that has, when x is 0, has y 4 is this one. All the other tables, answer choice C, all the other tables have the incorrect y-intercept. A's got a y-intercept of 11, B's got a y-intercept of 0, and D's got a y-intercept of 0. You can also guess and check by typing the tables into Desmos. However, that probably would have been a lot slower. Okay, question 6. This is just like the question we did a couple questions ago. So to find f of 21, I'm going to replace all the x's with whatever's inside the parentheses, the input, 21. So 4 parentheses 21 to the negative 1. And you can just type that in your calculator, honestly, but since someone's probably going to ask, rules of exponents tells us that when we have a negative exponent, we have that base of that exponent jump to the opposite side of the division bar. So 21 to the negative 1, it's going to be 21 to the 1 on the bottom. And 21 to the 1 is just 21. And I can't have an empty numerator, so we're going to put a 1 up here. So this entire thing, just using rules of exponents, is 1 over 21. 4 times 1 over 21 is 4 over 21, which gives us answer choice C. We can also do this one entirely on Desmos. Let's go do that. Okay, so I have the function typed in. Now we are going to just type in f of 21, and then we'll click on the fraction button. And we also get 4 over 21. Okay, question 7. So they want us to pay attention to the increase in the estimated population, which is y. So we're looking at y values from x equals 0 to x equals 1. So when x equals 0, we get a y value of 6. And when x equals 1, we got a y value of 9. So it goes from 6 to 9. That's an increase of plus 3. And 9 divided by 6 is 1.5. So it's another way to phrase it would say it's an increase of times 1.5. So I'm looking for an interface that says one of those. They all say times in it, so it's not plus 3. So it must be the one with the 1.5 times. And that is answer choice B. Okay, question 8. So it's really important, guys, that you understand that the predicted y values come from the line. So any y value that's actually literally on the line. And the actual y values come from the dots. So like literally where the little circles are. So just make sure you kind of understand that. Anyway, so question says we want to know for how many of the 11 points does the line predict a greater than, or y value that's greater than the actual. So we want to find predicted is greater than actual. So these little inequalities, they make way more sense if you write it with actual on the left. They don't always give you actual on the left. You see they didn't here. So I'm going to flip the inequality around. So like actual and predicted, I'm going to make them switch places. And then when you flip an inequality, you have to also flip the sign. So an equivalent way to write predicted is greater than actual is less than predicted. So now I go, okay, actual is the dot. So the dot is less than predicted, the line. So that means we are going to look for how many are below the line. So I'm going to circle them. 1, 2, 3, 4, 5, 6. So there are 6 data points below the line of best fit. So the answer is 6. You got to be really careful writing out those inequalities. Go word for word and then make sure actual is on the left side of the inequality. And you got to get it like that if it's not already like that. They're hoping that you hear this word greater than and you just instinctively circle the ones above. But as you see, that's wrong. That would give you the wrong answer. Okay, question 9. So we can do this one by hand, sure. So y is by itself for both of them. So substitution is definitely going to be the easiest. So I'm just going to essentially just set them equal, right? Because y is by itself. Technically substitution, but I don't know. It's just really convenient when they do that. They do this a lot on the SAT. All right, so I'm going to get the x's all to one side, and I'm going to get the numbers all to the other side. So when I get all the x's to the left side, so I'll add x to both sides. And at the same time, I will move this 14 to the other side. So I will add 14 to both sides. So 1x plus 1/3 x is 4/3 x. You could clear the denominator at the beginning if you want, but maybe a little bit of wasted time for such a short question. And then 18 plus 14 is 32. If I divide both sides by 4/3, I get x is equal to 24. We can also do this one entirely on Desmos, so let's go do that. Okay, so I typed in the two equations, and now I'm just going to zoom out using my scroll wheel. I click on the solution, and I see the x value to the solution, which is what the question wanted, is 24. Okay, question 10. So this is finding the equation of a line from 2 points. You just got to be really careful because in the order they give it to you. So you see it's 228, but like x is the items. So it's really 8, 220. Lots of people would have just wrote down 220, 8. So just pay very close attention to what they told you x was and what they told you y was, the function. All right, so the other point, again, it's not 320, 10. It's 10, 320. First thing we're going to do is find the slope. To do that, I will label the first point x1, y1, and the second point x2, y2. And then I will use the slope formula y2 minus y1 over x2 minus x1. So that is 320 minus 220 over 10 minus 8. So that should give you 100 over 2, which is 50. So the slope is 50. We will next write the partial equation, y equals mx plus b. Because the slope is 50, we have y equals 50x plus b. And then we will plug in a point to solve for b. So how about I use 10, 320? So 320, doesn't matter which one you use as long as it's on the line. 50 times 10 plus b. And then how about I come up here? That's 320 equals 50 times 10 is 500 plus b. And then if I subtract 500 from both sides, I get negative 180 equals b. And that means if we put that back into our partial equation, that y is equal to 50x minus 180. And that is answer choice D. We can also do this one entirely on Desmos, so let's go do that. All right, so all I'm going to do is make a table, type these points in. Pressing tab in between each entry to move on to the next field. And now I'm just going to type in the regression for slope-intercept form. and I see that let me locate these points first. Always make sure that the line goes through the points. You don't want to have made a mistake or something. And before I jump to the final answer, I'm going to translate these parameters to an equation. So m is 50, b is negative 180. So y equals 50x minus 180. And you see that perfectly replaces my regression, and it goes through the 2 points. So it seems like we did a good job. Okay, question 11. I do a problem exactly like this in my Ottocento number 6 on linear systems. I'm just going to assume you've watched that. Definitely go check that out. All right, so let's see here. First thing I notice is that right side is not in slope-intercept form. You don't have to do this, but I really don't like that 2 being there. So I'm going to multiply both sides by 2. So I get 8x plus 24 equals ax plus 3. And we still don't like that. We want to get the right side in slope-intercept form. So let's distribute that a. So 8x plus 24 equals ax plus 3a. Lines with infinitely many solutions have the same slope and the same y-intercept. So same slope. The slope of the left side is 8. The slope of the right side is a. Same means to set them equal. So 8 equals a, or in other words, a equals 8. And that is the answer. We can also do this one entirely on Desmos. Let's go do that. Okay, guys, remember for nature of solutions questions, it is beneficial to us to break the equation up into a system. So y equals left-hand side, y equals right-hand side. So that's what I did. Now, because it's multiple choice, this would be kind of hard to do actually without the answer choices, but because this one is multiple choice and because all the values of a are the answer choices, we can do this one. So let's just guess and check. A equals 0. Okay, that's not infinitely many solution, that's one solution. All right, let's try a equals 3. That's also one solution. Let's try a equals 8. Oh, that's infinitely many. I bet that's the answer. And let's try a equals 12. Oh, that's also one solution. So the only value of a that gives us infinitely many solutions is 8. Okay, guys, question 12. Definitely go check out my Ottocento number 1 on percents and my shorts on percents. And I wrote the equation for these story problems as old times percent multipliers equals final. That's really winded. I've stolen this from Satele Tutoring's video. He has a great video on percents. You should definitely go check it out. So open, old percent, e means equals, new, open. It's just a word, right? Just the word open. That's how you remember what you do for a percents story problem. So the old price was $15.50. The percent we don't know. And the new is 17.36. I'm going to solve for the percent multiplier, the p. We divide both sides by 15.50. And I get a p of 1.12. So now this is really important. This is where most people watching this probably got this wrong. It says p percent of. To go from a multiplier to a percent of, you multiply by 100. So this would be 112% of. And that is answer choice C. Lots of people probably picked A, which is wrong. And it would be right, though, if the question says something like something that sounded like a percent increase. Like, let's say instead of p percent of, it said p percent more or p percent greater, something like that. Because to do a percent change, what you do is once you get that percent multiplier, you have to subtract 1 first, then multiply by 100. But for percent of, to go from the multiplier to the percent, all you do is multiply by 100. Hopefully that helps. Okay, question 13. So this is a linear quadratic system, so if you're going to do this by hand, you should really use substitution. So I'm trying to look in both of them like, what would be a really easy thing to get by itself? And I think this y would be pretty easy to get by itself. All I need to do is add y to both sides. So I get 8x plus 16 equals y. Now that I have this, I can substitute into the top equation for y. So we get x squared plus 8x plus 16 plus 10 equals 10. And if I subtract 10 from both sides, and those parentheses don't really do anything, I just did that for the sake of teaching. So remove those parentheses and then subtract 10 from both sides, and you get x squared plus 8x plus 16 equals 0. This is factoring with a equals 1. You could also use the perfect square trinomials formulas. That's all covered in my Ottocento number 4 on factoring. So definitely go check that out, Ottocento number 4 on factoring. And so adds to 8 multiplies to 16. So that's 4 times 4 and 4 plus 4. So we're going to do x plus 4, or in other words, x plus 4 squared. And now I use the zero product property. So x plus 4 equals 0. And x is equal to negative 4. Subtract 4 from both sides. And that gives us answer choice B. We can also do this question entirely on Desmos, so let's go do that. Okay, so all I did was just type in these two equations verbatim. I'm going to see where they intersect. They intersect at negative 4 comma negative 16. Question wants the x value, which is negative 4. Okay, question 14. So this is a literal equations question. I look where it says in terms of, and the letter that comes right before that is the letter we want to get by itself. So that is A. And just kind of looking at it, let me rewrite this so that I can show you the algebra. I see that the A is being multiplied by 8 parentheses B plus 9. The opposite of multiplication is division. So I'm going to divide both sides by 8 B plus 9. All right, and you see these guys go away, and we're left with A equals x over 8 B plus 9, and that is answer choice B. Okay, question 15. So for this one, it just wants us to multiply these guys together. So g of x times h of x, so 3/5 x plus 7/6 times g of x, which is 6x minus 5. And now we're just going to do binomial distribution using like first, outer, inner, last. So first, 3/5 x times 6x. 3/5 times 6 is 18/5, and then x times x is x squared. Now I'm going to do outer, so that's this one and this one. Negative 5 times 3/5 is negative 3, and x times, there's no x in the other one, so it's just x. Now if we do inner, so that's 7/6 times 6x. 7/6 times 6 is 7, and there's just one x, so this is plus 7x. And then last, so 7/6 times negative 5, that is negative 35/6. We now combine the like terms. Negative 3x plus 6x is 4x. So we get 18/5 x squared plus 4x minus 35/6. And that is answer choice D. We can also do this one entirely on Desmos, so let's go do that. Okay, so I just typed in the two equations. Now I'm going to type in g of x times h of x, and that's all I care about. So let's unhighlight those first two. And now you start guessing and checking, typing in the answer choices. I'm not going to go through all that. Why don't I just do the correct one? So 18x squared over 5 plus 4x minus 35 over 6. And you see it says equivalent. Equivalent means they have infinitely many solutions. The answer choice D, the purple one, perfectly replaces the green one. So that means it has infinitely many solutions. Okay, question 16. So the first part says the product of two positive integers is 462. Product means the result of a multiplication. I'm going to call the two integers x and y. So x times y equals 462. And then it says the first integer, which I'll call x, is 5 greater than twice the second integer. So x is means equals twice the second integer, that's 2y, and then 5 greater would be plus 5. Okay, so now we've got x by itself, so I would just substitute, put this guy in here, and we get 2y plus 5 times y equals 462, and that gives us 2y squared plus 5y, and then I could subtract the 462 to the other side. I don't know, guys. Hopefully you're kind of seeing doing the AC method and the quadratic formula with such big numbers, like 462, is kind of impractical. So I would probably just write the first two equations and then do this on Desmos. So let's go do that. Okay, guys. So I typed in the two equations, and now I'm just going to zoom out. And it looks like there's two solutions to this system. That one I just clicked on can't be right, though, because it says they're positive, and it also says they're integers. Negative 16.5 is not an integer, so it's kind of wrong for two reasons. Let's look at this one. 33, 14. So x is 33, and y is 14. We want the smaller of the two integers, so our answer is going to be 14. Okay, question 17. Guys, I go over how to do all of this, literally like this exact question, in my Ottocento number 5 on function translations. I'm just going to assume you've already watched that. All right. So to perform a function translation, we're going to use an explicitly defined function. We're going to use g of x equals f of x minus h plus k. So the question says it is shifted up 6 units. So the horizontal translation, h, is just 0. There is no horizontal shift, but there's a vertical shift of up, 6 up. That's the positive y direction. So that means k is positive 6. So we're going to write g of x equals f of x plus 6. And this entire thing here is f of x, so that's just going to go here. So g of x equals x minus 1, x plus 3, x minus 2, plus 6. And the question says 4 comma b is the point. So we're going to plug in 4 comma b. So b is the y, and then 4 is the x. And we can also, we can now just put this in a calculator, and you should get b equals 48. And that is the answer. We can do the bulk of this problem on Desmos, so let's go do that now. Okay, so I typed in the function, f of x. Now I'm going to type in g of x equals f of x plus 6. So really, that was the only part for this question that I had to come up with. was g of x equals f of x plus 6. That's why knowing how to write that notation is really helpful, because Desmos can do function translations for you. All right, so you can look at the picture. You see it kind of moves 6 up. And so that's a good sign. And the question says 4 comma b. So is 4x or is 4y? Well, x is 4, so I could type in x equals 4 and see that y or b is 48. Because they gave us an x and we're looking for y, we can also use function notation. So if I type in g of 4, I also get 48. Okay, question 18. So this is testing us on d equals rt. Common way teachers write this is like they put it in like a little pyramid so that you understand all the 3 forms. D equals rt, r equals d over t. See how like r is equal to d over t, and then t is equal to d over r. Anyway, so we are going to find first the speed, the rate of object r. So that is equal to d over t. And they tell me that object r travels a distance of 4x inches in y seconds. So that means the rate of r is equal to 4x over distance over a time of y. Now it says that the speed of object r is half the speed of object s. So if the speed of r is half the speed of object x, that means the speed of object s is double. Hopefully that kind of makes sense. So we're going to do 2 times the speed of r, which is 4x over y. And that gives us 8x over y. Now we're going to come over here and try to actually answer the question. We want to know the time for object s. So time is equal to d over r. And the question says his distance is 24x. And his, we figured out before that his rate is 8x over y. So when you divide fractions, it might be easier to just do it left to right. So 24x, and then instead of divided by 8x or y, you can multiply it by the reciprocal y over 8x. And I see the x's go away, and 24 divided by 8 is 3. So for TS, I get 3y. And that is the answer. Answer choice B. This might have been harder, but perhaps another thing you could have done is maybe you could have came up with some numbers for like the speed of, for like x and y, and then like use that to come up with the speed. Maybe you could have made x 6, and then you could have made y 2 or something like that. And you could have just done all the calculations with tangible numbers and then guessed and checked. That's another way you could have done it. Great, let's keep going. Okay, question 19. Okay, guys, so this is testing you on something called factor theorem. So factor theorem tells us that if k is a root, then x minus k is a factor. So basically, whatever makes that factor equal to 0, this part right here, is also going to make the entire function equal to 0. So I'm going to go off to the side and see what makes the factor equal to 0. Well, if I add k to both sides, add x to both sides, I get k equals x or x equals k. And that tells me that that is a root or an x-intercept. So the point k comma 0 satisfies this little function they gave us up here. So first thing I'm going to do is I'm going to plug in k comma 0 into that equation. So negative k squared plus 1 over 29 n k squared is equal to 0. So I made the xk, and then I set it equal to 0, just like the point told me to do. And I'm just going to rewrite this using the commutative property of addition, just to make what I'm about to do a little bit easier for you guys to see. I just changed the order. I didn't change the value of the expression at all. I just switched it around. Okay, so now I'm going to factor using a GCF, which I go over in my Ottocento video on factoring. So the greatest common factor is k squared. And you see, guys, if we kind of, when you're factoring, you're kind of like pulling out a GCF, you're kind of like dividing in a way. So you see I'm left with 1 over 29n minus k squared over k squared. K squared divided by k squared is 1. Just like how 5 divided by 5 is 1. Okay, so now I'm going to use the zero product property. So either k is equal to 0 or 1 over 29n minus 1 is equal to 0. So k is equal to 0 or 1 over 29n minus 1 equals 0. I'm going to add 1 to both sides. I get 1 over 29n equals 1. And then I'm going to multiply both sides by 29. And I get n is equal to 29. So either k is equal to 0 or n is equal to 29. Now the question tells me k is greater than 0. So k cannot be equal to 0. It has to be positive. So this is not our answer. The thing that we learned from this question is that n is equal to 29, which is answer choice D. I actually think Desmos might be some help on this one. Let's go see. Okay, guys, so all I did was typed in the function in the question. I just called it q of x for question. I labeled the root, which we determined was k comma 0, using the factor theorem. And then I made k equal to just some random positive number. Don't do 1, like do 2, 3, 4, 5, something like that. And now I'm just going to start guessing and checking, and we're going to see if this graph goes through the root. So let's do n equals negative 29. And that does not go through the root. Let's try negative 1 over 29. That does not go through the root, so it means k minus x is not a factor. Let's try positive 1 over 29. That also does not go through the root, so that means k minus x is not a factor. And now let's try positive 29. Ah, looks good. That goes through the root. So there was still a little teensy bit of work you had to do. You still had to figure out that them telling you that that factor was a factor told you one of the roots. But once you figured that out, we could use the answer choices to guess and check really quickly. Okay, question 20. So this is actually, even though you don't need to understand this at all to do the question, this is a function translation. And f of x minus h plus k, we got to change the sign of h. So it's not negative 4, h is positive 4, because there's a minus in front of h in that expression, f of x minus h plus k. I go over that in my Ottocento video on function translations. So this is a translation of 4 to the right. Anyway, it doesn't matter. You just need to know function notation. So h of x is equal to f of x minus 4. So wherever you see an x, you're going to replace it with whatever's inside the parentheses, in this case, x minus 4. So g of x, h of x is equal to 272, 2 to the x minus 4. I just replaced that x with an x minus 4. Now I am going to use reverse rules of exponents to break this up. So if we multiply by a common base, we add the exponent. So I can rewrite this as 2 to the x times 2 to the negative 4. because 2 to the x times 2 to the negative 4, x plus negative 4 is x minus 4. So it's kind of just like doing that rule of exponent that you're probably really familiar with. It's like doing it backwards. That's why I call it reverse rules of exponents. Again, doesn't matter. So you'll see in all the answer choices, they just have 2 to the x at the end. So we're going to combine these two. If you type in 272 times 2 to the negative 4 on your calculator, you should get 17. So this is 17 2 to the x. And that is answer choice A. We can also do this one entirely on Desmos, so let's go do that. All right, so I just typed in the function, and now I'm going to type in h of x equals f of x minus 4, exactly as it's in the question. And you'll see that it indeed did move 4 to the right. And I don't care about f of x anymore, so let's unhighlight him. And now I'm just going to start typing in answer choices and see if it's equivalent. And man, that is lucky. The first answer choice is equivalent to h of x. I'm not going to do it, but I bet if you typed in B, C, and D, it would not look the same as the blue graph. Okay, guys, question 21. I did the drawing off screen so that I could try to make it as clear to you, for you guys, what is happening in this problem. But before we do that, you need to know how many degrees are in a pentagon. So the sum of the interior angles formula is 180 n minus 2. So I'm going to do 180, n is the number of sides. So there's 5 sides in a pentagon. 5 minus 2. So 3 times 180, you should get 540 degrees. So there's 540 degrees in a pentagon. Is it worth it to just memorize how many degrees are in a pentagon and a hexagon? Maybe, because they do like to use those shapes a lot on the test. All right, anyway, so it says that segment AB is parallel to DE. And I tried to draw it that way so that would make more sense to you guys watching. All right, so it says the measure of angle B is 139 degrees. And the measure of angle D is 174. And we want to know the measure of C, which is X. So maybe there's another way to do it, but what I basically did was, guys, I noticed that these two angles are what's called same side or consecutive interior angles in parallel lines. And that means they add up to 180 degrees. So we don't know what the blue angles are, but we know they add up to 180 degrees because they're same side interiors. If you're having trouble seeing that, what I really like to do when there's parallel lines in a shape is I like extend the lines going off to the side of the shape. And you can see, oh, they're on the same side of the transversal. They're on the same side of the transversal, and they're on the inside. If you think about the parallel lines like a sandwich, they're on the inside of the sandwich. So it's one of probably 4 or 5 facts you got to know about parallel lines. The same side interior angles are supplementary. They add up to 180 degrees. Anyway, so the blue ones as a whole are 180. And then we're going to do plus 139 plus 174, and then plus x, which is equal to 540. And you can add up those first 3 numbers and then subtract it from 540. And you should get x is equal to 47 degrees. And that is the measure of angle C. That is the answer. Okay, guys, question 22. So to do this one, you're going to need to know the discriminant. So definitely go check out my short on the discriminant. If you go to my shorts tab and sort by popular, it should be the top result because that was one of the first ones I uploaded. So first thing we're going to do, I'm just going to assume you've watched that. So first thing we're going to do, I don't like that square root there, so I'm going to square both sides. This radical will go away because square and square root are opposite operations. So I get k minus x equals 58 minus x squared. And we're going to do 58 minus x times 58 minus x. We're just going to expand that. And if you FOIL it, you should get x squared minus 116x plus 3364. And now we're going to get all the terms to one side, put it in standard form so that we can use the discriminant. So I'm going to add x to both sides. And then I will also subtract k from both sides, kind of at the end over here. These guys will go away. And we get 0 equals x squared negative 116 plus x is minus 115. X plus 3364 minus k. Now I'm going to identify a, b, c, x squared plus bx plus c. A is what's in front of x squared, so a is 1. B is negative 115. And c is this constant term all the way at the end. Anything without an x in it is part of the constant term, so this big mess is the constant term c. All right, we know from the question that it has exactly one real solution. When a quadratic has one real solution, we know from the discriminant that b squared minus 4ac must be equal to 0. All right, so we're going to put in negative 115 squared minus 4, a is 1, and c is 3364 minus k. Negative 115 in parentheses squared is 13225. Negative 4 times 1 is minus 4. All right. So now I'm going to distribute that stuff on the right there. So 13225. Negative 4 times 3364 is minus 13,456. Negative 4 times negative k is plus 4k. And I think the question actually wants us to find 4k, so why don't I just solve for that? So 13,225 minus 13,456, combine the like terms. Forgot to put a 6 there, or it didn't register. Okay, so I get negative 231 plus 4k equals 0. And I get 4k equals 231. And if you divide both sides by 4, you get k equals 57.75. We're going to use this to check it on Desmos to make sure we did it right. But you'll notice, guys, the question wanted us to find, for whatever reason, wanted us to find 4k, which, as we just established, was 231. Let's use Desmos to check our answer to make sure we did it right. Okay, guys. So, whenever we want to figure out the nature of the solutions, we break up the equation into a system. So I typed in y equals left-hand side, y equals right-hand side. I then typed in what we got for k, and then 4k just to show you that it does give you 231. So now we're going to see if k equals 57.75 gives us one solution. So I'm going to zoom out. And it seems there is exactly one solution, and it's right there. Seems like we did a good job. Could you have used the slider to figure this out? Maybe. But what if the answer wasn't 57.75? What if it was like, 123 over 7? That would be a lot harder to get the exact answer. So what I suggest you do is use this to check your answer. If you're moving faster on the earlier questions, what you can do is you can spend extra time on these ones towards the end. And you could say, let's say I thought it was k equals 30 or something, okay, I could see that that has no solution, and then if I have time still, I could try again and see if I can get the right answer. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. And if you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.